thanks a lot for the introduction. Yes, first of all, a few words about my person. I prefer to work in infrastructure and especially network-related topics. During my time at the University of Würzburg, I was doing research mostly on software-based networks. Now, a year ago, I joined a company called Amplify, which runs a virtual mobile core network tailored to, well, connecting IoT devices. As this differentiates us from most other network operators, we're not just buying our equipment from some vendor, but instead we're developing all these infrastructure on our own. So this core network, which is based on Akka, runs since roughly 4 years. And well, over the last past months, while our customer base and especially the number of connected devices has increased a lot, it turned out that we kind of need some better insights into the performance of our application. And that's actually why I'm here today. I want to introduce you to Kamon, which is our tool of choice, and how we can collect metrics using Kamon. Then the additional tooling that you need for actually like storing these data. And well, I only got 30 minutes, so only a few words about our own experience with it at Amplify. What can application performance monitoring do for us? In an Akka context, we can, for example, get statistics about the time in mailbox as it develops over time for one particular actor. So when your time in mailbox goes up to the 30 seconds, your response times are getting very, very bad. Nagios didn't tell it to us. We saw, oh well, we're experiencing timeouts a lot, but the CPU load wasn't increasing on any of the nodes in our cluster. Because when you have only one actor instance per node, that's not burning all the CPU. So you really need to look inside the application to find these things out, which are of course very critical. The tool of choice that we are using here is Kamon. Kamon is an open source project. My relation to it is that we are happy users and I have a Kamon t-shirt. All the credits actually belongs to the Kamon development team. In general, Kamon offers monitoring for the JVM, but it has very, very good integrations into Akka and, well, I would say our ecosystem. And end of last year, when we again looked a bit at monitoring, we suddenly saw, oh, there are 1.0 snapshots available in Kamon, and there are many, many refactorings going on. So for those who have used Kamon in the past 5 years, because it's not that young actually, many, many things have changed compared to version 0.6. But this January, the development team, so to say, declared maturity of their project and released version 1.0. The feature set of Kamon can be categorized into 2 parts. The first is tracing. The other one is metrics. Regarding tracing, we're collecting call graph information for one request. When it goes across our actor system or across our cluster, one central node collects all this information. Because of some correlation IDs being passed across the Akka nodes, we can correlate this together and really follow one single request, how it goes through our cluster, and hopefully responds quickly. We can do with that profiling on a per request level. We can see where is a certain request spending most of the time in the system. But actually, like maybe after a few years, you forgot which part of the system are actually involved in handling a certain request type. So this gives you this insight into how your actors and different nodes are involved for handling one single request. I conducted one trace. I'm sorry for the very low resolution, but here for every single line we have one actor receiving a certain message. Then we see, usually in the microseconds, the processing time of this. The different colors tell us that it was a different node in our cluster. And like here, the big yellow part, that's of course the database query. We can then click on one such line and get even the executed SQL query together with, well, the time it took to execute. So this gives us very, very valuable information on a per request level. When we're talking about metrics collection, we're talking about values that change over time. So time series data stored in a counter or also distributions of certain values. We can, for example, track how often we call a certain function in our code and how long it took to respond, how many database connections are open, but also more business-related metrics like how many user logins did we handle, what's the generated revenue, because if any of these numbers goes down, there's probably something wrong. Because of the time constraints, I'm focusing on the metrics part. Tracing is, of course, yet another very interesting topic. Metrics is again, so to say, divided into 2 parts. The first is custom metrics. So in your code, in a certain line, you decide, okay, it might be valuable for me to know the value that is stored in this variable, things like that. And you explicitly add one line, Kamon something, please track this value, and then you get statistics out of it. That's where you decide in your application things are worth to track. The other type is the so-called automatic instrumentation. Without writing any line of code, usually just by pulling in a few dependencies, Kamon gives you insights into your Akka actor system. That's what I'm focusing on today, but also more and more other frequently used libraries. In addition, we get metrics about the system like CPU load, JVM metrics like garbage collection time, all of that without writing a single line of code. When we now want to add custom metrics for our code, we have the obvious choice of a counter. So every time we call a function, we increment the counter. The gauge, in contrast, can also decrease. An example would be every time we open a new database connection, we increase the value. Every time we close the connection, we decrease it. So we get a statistic about how many database connections are open. In contrast to those two more simple types, which return one value when metrics are collected, like every 60 seconds you collect metrics, you get number of database connections is X. The other types that follow are mostly based on histograms and are a bit more complex, but we want to store actually latencies or how much money people spend in our shop in histograms, which gives us a distribution as average averages are usually lying on us. Histogram for one metric collection looks as follows, for example. On the x-axis, we have predefined buckets. So in steps of 5, we track the observed value. And we see that here, okay, for example, when we talk about latency, 15 to 20 milliseconds has been the order of magnitude of the latency that was also observed most frequently. And plotting this over time is, of course, then yet another challenge. But that's for one collection, which gives us a lot more information than average. Because storing or tracking latencies is such a frequent use case, Kamon has also one helper, which is a timer. You give it a name, you start it, later you stop it. That's it, you get a histogram. And you don't have to ask Java for the actual time yourself. One speciality of Kamon is the so-called range sampler. Again, we can apply it to, for example, the number of open database connections. And I said we get one value, for example, every 60 seconds, but many things happen in a minute, right? You don't know if you just captured your system during a peak or if there was some peak and you then totally ignore it and so on. The range sampler by default probes the value every 200 milliseconds. And then when metrics are collected, so after a minute, it returns the lowest observed and the highest observed value. So this gives a lot of more insights. For example, when you're talking about queues or mailbox sizes, when your queue never goes down to 0, your system is constantly queuing up work, you're slowing down your request unnecessarily, so certainly an operational mode that you don't want. It's fine if the queue goes up, but it's important that it can also actually empty it. So how can we implement this code-wise? Pretty easy, you call kamon.counter, then you give it a name, and you can increment that counter. Similar, when I want to query here the audience as age, I set up a histogram, kamon.histogram, give it a name, and then I'm asking each one here about that person's age. It doesn't matter, we don't have to pass this object around. Every time we instantiate one counter with the same name, it ends up in the same data. Age is here again, probably a good example again why an average would absolutely lie. I mean, when the average is 20, I can't differentiate if I have students at a university with an average age of 20 or parents and their children. So averages, please forget it. Histograms are ruling metrics. Another nice concept to provide a bit more detail to such counters is that you can, well, set up a participants counter, for example, here for this whole conference, but have here with refine sub-counters. How many are at the ReactSphere, how many are at the scalar sphere, and then you increment these particular counters. And later on, you can say, okay, I'm not interested in like these sub-counters, give me the total numbers, or yes, you can query it for particular details. And you can have more than also one key value pair, of course, assigned to certain metrics. That's especially very powerful with Prometheus and this well, multidimensional data model. my favorite feature of Kamon regarding automatic instrumentation is Kamon Akka. I assume basic familiarity in the audience with Akka, but the major point is that we are sending messages or putting messages in a mailbox of an actor. This actor processes the message and then usually forwards it yet into another actor's mailbox. And when you have either slow processing times or many messages in the mailbox, your application is slow. From a high-level perspective, we get information about our whole actor system, like the number of processed messages per second. This gives us an indication if we're currently experiencing high load or it's just the normal case. But what's really powerful is then the matrix that we get on per single actor level. So for every actor in our system, we get the two critical values, which is processing time distribution per message and the time in mailbox. And with only these two values, we can very good follow the flow of a message through our system and figure out, well, by looking at which actor has the highest time in mailbox, which actor has the slowest processing times, we can easily figure out what's actually the bottleneck of our system. In addition to the per actor metrics, we get similar statistics for routers, dispatchers, executors. There's the feature of actor groups, more on that later. And we can also get information about Akka remoting by pulling in another dependency, so serialization times, how many messages are we sending across the cluster, and so on. To add this instrumentation, Kamon actually uses AOP, so you need to start your application either with Aspect JWeaver, or there's the Carnela Kamon agent, which I would consider at the moment a bit an experimental state as a lightweight replacement for Aspect JWeaver. So Kamon is now running in our application, and we need some additional tooling, of course, to store this metrics and to display it and so on. The tool stack that I suggest to you today is with Prometheus and Grafana, completely open source, which you can also host on your own. But I've put or categorized a few other projects that you might have heard of so that you easily understand what actually Prometheus and Grafana is and why I'm talking about this. Yeah, Prometheus, the tool of my choice, is a time series database, so it takes care of collecting the data, storing it, and giving us a way to query this data. In contrast to most the other monitoring systems that we probably know, it follows a pull-based model. So not all the servers are sending the data to a central monitoring system. It's the other way around. Prometheus scrapes, so it queries the data from the particular nodes, and therefore they have to expose this information via HTTP. Prometheus is super easy to deploy. It's a statically linked Go binary. It's a very tiny YAML file. Those two things, and you're ready to go. If you need alerting, Prometheus also has an answer for this. But a few more details about the integrated time series database. The reason why it's that easy to deploy is, well, it writes all this data just on disk. It has no external dependency like Cassandra or something that you need for other time series databases. Most people that I talk to have like tens or a few hundred of gigabytes of time series data on disk, so it's not that massive. One fact which felt, at least to me, a bit uncomfortable in the beginning, Prometheus has no concept for long-term storage. So you get the full resolution of your data by default for 15 days, and then the data is deleted. Well, because of these assumptions and a few others, Prometheus is extremely efficient and performant. So every data value that it stores is compressed to less than 2 bytes actually on disk. The PromQL, the query language that it provides, well, gives us then the means to query this data and make calculations out of it. Yeah, how does the setup then look in a bigger picture? We have Kamon inside the application, Prometheus as time series database scrapes the data from it, and Grafana as dashboard, where we enter our PromQL query. Grafana does a few things with them, sends them to Prometheus, and we get back diagrams. Yeah, in addition to data from our application, we can use many more so-called exporters which are available by the Prometheus community. The node exporter gives us metrics about the host where it runs, CPU, network utilization, things like that. CAdvisor does the same for containers. But there are also exporters available for all databases, all web servers, whatever you need. So as we said, Prometheus now queries data from all these targets that's why Prometheus has actually to know what are my targets. This can be either configured statically, but in our fast-moving world, you probably better hook it up with some service discovery system like Consul, or point it to AWS APIs, Kubernetes API, and so on. And that's how Prometheus knows where to query data from. More technically, the output that is provided to Prometheus looks as follows. So that's the port of Kamon, and we get, for example, here the checkouts of how often have these SIM cards been sold, for example, interleaved with, well, these automatic metrics, for example, about dead letters in our system. From QL, in this very simplistic Prometheus UI, I give it the name of the metric that I want to query, and for example, there is a range function which gives me the change of this counter here over the past 5 minutes. And what are 224 dead letters? Is it running since an hour, or is it running since a year, this application? Every time we start our application, counters are at 0. Things like these counter resets or counter overflows, those are handled by the functions in Prometheus, so that data can also be aggregated and, well, the things that happen when such data is stored. And yes, this function, for example, tells us, okay, in the past 5 minutes, nothing wrong happened. And tools like Grafana query this for different times and then build a graph out of it. Yeah, well, I often talked about Grafana. Actually, it's a pretty simple front end for me. It's the obvious choice for dashboarding. I configure my dashboards, give it some PromQL queries, and I get very nice graphs back. There is a Kamon Akka dashboard, which we helped to build, which you can download from the Grafana dashboard site. An example that it gives you is here the mailbox size for a particular actor, or actually it's the 95th percentile of the mailbox size of a certain actor. Treat this as a starting point to build your own dashboard, but there are a couple of examples in this dashboard. So what's our experience at Amplify with this stack? Well, I have to keep it short, unfortunately. One configuration, besides tuning a few values, one of the more important things is that the tick interval, how it's called in Kamon, and the scrape frequency, how often, well, Prometheus queries data from Kamon has to match. The good thing is by default, both is 60 seconds, but otherwise, Prometheus gets like no change because Kamon didn't refresh its data. So then you would get zigzag graphs and so on. So make sure that this matches. Most people with whom I talked run Prometheus with scraping frequencies of like 30 seconds. We mostly used it for load test until now, this stack, and we went down for 5 seconds. We're in the process of bringing this into production really with Prometheus. I hope to settle for like 50 seconds because, I mean, we have 5 seconds of maybe when a link is down and you get double the requests afterwards, and the higher your aggregation interval is, the more likely is that you will not notice this in your metrics, but your application totally goes crazy because it gets a higher request rate. So that's something that you probably have to tune a bit. The deployment for us, well, that felt pretty easy. Our test environments that we bring up, EC2 instances via CloudFormation, they are already tagged, and this tag gives us the information that actually a node is running Akka and which Akka role is it running, and we could really feed this information one-to-one into Prometheus just by pointing it to the EC2 APIs. For actually running Prometheus, we went a simple path. We run Elastic Container Service, so some Amazon hosted Docker thingy, and we just launched a Prometheus container there, which is fine for our scale that we did. Except, well, there was one thing how we, during a few days, killed Prometheus very, very, very often. And the reason for this was, yes, of course, in this container, we have not that much CPU resources assigned. We have, well, shared file system NFS, certainly not the most clever idea. If you have better setup, the bar would be higher, but high cardinality will kill you anyways. That's why I want to talk a bit about this. So what's high cardinality? We said we get data, time series data for every single actor. So we get a few different metrics per actor, and because we have histogram buckets exposed, we are at roughly 65 metrics per actor. So if we created 100,000 actors, well, Prometheus explodes. And the reason for this are actually unnamed actors. You see it here with the dollar. This generates many, many time series, and this happened to us frequently in the beginning. And then well, we killed Prometheus. So how can we fix Kamon that it doesn't kill Prometheus? Actually, there's this concept of actor groups. So in Kamon config, we say, okay, I want some group for my actors. We exclude, based on pattern matching, these actors from the normal Akka tracked actors and put them instead into a certain group. To then recover Prometheus, well, we actually had to delete all its data, which is fine for us because we've used it for load testing anyways. But there's actually not that super easy solution or alternative. If anyone is aware of something, please tell me. And then we continued to watch out for, well, again, metrics with dollars in the actor path to appear to then set up yet another actor group. But actually, when you point Chrome to the HTTP endpoint and Chrome freezes because the output is that large, you know that you just messed up once again. One thing that we also learned in the meantime is how we can configure Prometheus that it doesn't get this kind of overload. There's one option in the scrape configuration which is called a sample limit. We set it to some thousand, and every time this limit is exceeded, well, Prometheus would just drop this information and instead increase an own internal statistics counter that we can watch for. One kind of bonus, or maybe call it also advertisement, which I didn't know at the time when I handed in this topic, this talk, is Kamino. But as it really helped us a lot when we noticed that we actually need production monitoring a bit faster than we thought. That's why I just wanted to introduce you to it. Kamino is a hosted service. So instead of this combination Prometheus Grafana, which because of whatever reason is not in production in our company yet, we replace those two parts with Kamino. As you might see when you look at the logos, this is related to Kamon, and actually it's a hosted service by the Kamon developers, which is currently in a private beta, but you can request an invite on the website. This then really helped us a lot because it's really made for Akka monitoring, and we got all the dashboards, all the data that we actually could get out with Prometheus on our own and build our own dashboard with Grafana. We just got it here, served in a very nice and very usable way. It can do things that Grafana can't, for example, to visualize distributions over time. That's at the moment not possible with Prometheus data source. And yes, it has still its few rough edges, few things are not yet implemented, but we will certainly also continue to use this service. Few screenshots from Kamino. For example, here we have ordered by the descending 99th percentile of the mailbox time our actors in the system, and we can figure out, okay, which actor has the highest times in mailboxes, and then we can click on one of these lines and get more additional statistics. These are only 3 of the statistics on a per actor level that we get, and that's what's actually one situation where we experienced, okay, we have one particular supervisor which is getting slow with a higher number of child actors that it created because the implementation probably wasn't thought of so many child actors. So it went up to the 20 milliseconds processing time. You have one actor, one instance of this actor in the system, and it's definitely a bottleneck. So when we restart the system, it's fast. When we create more actors over time, it's getting slower. We had a theory which line in the code was actually causing this issue. And when we deployed this fix, yes, we could prove that it actually fixed this bottleneck. So having these insights in the application was super useful to not only see where slow response times come from, where, overload of our system comes from, but also to prove our theory that, yes, it was this part of the implementation, and now we are back at some 100 microseconds of processing time for this very actor. Yeah, to summarize my talk, Kamon is really a great library for application performance monitoring. We have customized metrics where you add it to your code when you think it's valuable to track this value, but we also have automatic matrix collection. As it helped us really a lot, you're not bound to particular monitoring services or other tools. You can run it with open source on-premise tools like Prometheus and Grafana, or also Influx, but you can also use software as a service monitoring solutions like Kamino, but also Datadog. The community is super friendly. Ivan Topolniak helped us really so much in the GitHub chat. That was really amazing. And of course, yes, distributed tracing as yet another interesting topic, which is provided by Kamon. Yeah, my personal recommendation, start monitoring your application. You will learn many things. Better start it small. We didn't. We wanted to go all in. That's why we always delayed it a bit and so on. And well, then kind of in a firefighting style, we had to add the parts with Kamino that then really helped us a lot. So just add Kamon and Kamon Akka maybe to your system. Start a tiny Prometheus server because you will throw it away anyways a couple of times, and you should get nice insights into your system already. So that's it from my side. Thanks a lot for your interest. I'm happy to discuss with you. You can also find me then in the lunch break down at the speakers table. Thanks. Questions? Okay, of course. We're all hungry, I understand. Okay, see you.